Hello guys, welcome to today's topic, which is 2.6, the quadratic function. We're going to analyze in depth what this function is about, okay, which is basically the parabola. And you have seen it at some point in your life already, so you have some familiarity with this function. So let's see. What are the objectives for today? Number one, I'm going to introduce the main three forms or equations of the quadratic function. I'm going to refer to the quadratic function as QF, quadratic function. Number two, we're going to go from one form of the quadratic function to another by means of analysis or by means of doing some algebra. And number three, we're going to study the most important features of the quadratic function, something known as the concavity, its vertex, its axis of symmetry, its intercepts, and its domain and range. So this is actually the first function that we're going to analyze in detail. That's basically what I'm trying to tell you. So first, a little background. We're going to talk about the equations of horizontal and vertical lines. Okay, let's read. The equation of a horizontal line that crosses the y-axis at h is given by y equals h. It's that simple. So for example, looking here at this first graph. Okay, we have the Cartesian plane and we have this horizontal line. And you know, when we talked about the straight line in topic 2.1, I don't remember studying these two specific straight lines at all. So I apologize for that. So I'm gonna do that in here. Okay, it's very simple. It's actually very simple. So if you see this straight line crosses the y-axis at 2. Okay, right there. Okay, so how can we get the equation of this straight line which happens to be horizontal? Okay, it's very simple. All you have to understand is this: the particularity that all of these points possess, all of these points that form this straight line, all of these points, what common feature do they share? Well, all their coordinates, if you look at the coordinates of all of these points, since they are on the same line and that line is horizontal, you're gonna see that all of these points have y coordinates equal to 2. For example, this may be minus 4 point something. Let's say minus 4, okay? Okay. This point over here, this one right there, this point is minus 1 comma 2. Can you see? This one, this is 0 comma 2. This one over here, this one is 2 comma 2, etc. So all of these points share one commonality, and that commonality or that common thing is that their y coordinates, as you can see, they are all equal to 2. And that's the way in which we can describe this horizontal line. We say that this horizontal line is described by the equation y equals 2, because that's the place at which it cuts the y-axis. Okay, because all of its points, all of the points that form this horizontal line have a second coordinate, or as their y coordinate, they have y equals 2. So this guys, this is the equation for this horizontal line. The same with a vertical line. Look at this vertical line. We have the Cartesian plane, and this vertical line crosses the x-axis at minus 3. Okay, so all the points that form this vertical line, this point and this point and this point and this point, etc., all of them have a common feature, and that is that their x coordinates are always minus 3. For example, this point is minus 3 comma 1. This point is minus 3 comma 2. This one is minus 3 comma 3. This one is minus 3 comma 0, so etc. Can you see? So all the points in here share that common feature. Their x coordinates are always 3, and that is the best descriptor for this vertical line. This vertical line is described by the following equation. X equals minus 3. This is the equation of this vertical straight line, because all of the points that comprise this vertical line have this they comply with this requirement that their x coordinates are minus 3. So that's how you do it, guys. Okay, for horizontal lines, you look at the point at which they cross the y-axis, and that's going to be the equation. Y equals to that point, or that value. And the same for vertical lines. You look at what point, at what value it crosses on the x-axis. In this case it was minus 3, and that's going to be the equation. X equals minus 3, minus that value. Okay, so that's a little background. Okay, so subtopic number 1, the three main forms of the quadratic function are these. We have the standard form, which is f of x equals ax squared plus bx plus c. And then the factor form, which is f of x equals a times x minus b times x minus q. And then something called the vertex form, which is equal to this, f of x equals a times x minus h to the square plus k. These forms have to be exactly, you have to write these forms in this exact way. Every single sign, every single exponent, and anything and everything means something, and they have to be in the correct places. Okay, now another thing that I want to point out that is very important and that is very confusing at first is the following. The way in which you have to understand these forms, okay, all of these three forms, is this. I like to read them in this way. The standard form of this of the quadratic function is this: f of x equals some number, some coefficient, times x squared, plus some other number times x elevated to the 1, plus some other number alone, a constant. That's it, guys. You don't have, your mind doesn't have to interpret or to memorize that a, b, and c have a special significance. They're just numbers. If anywhere else in any other book or whatever, if you saw something like this, let's say m x squared plus n x plus r. Okay, look at this. Look at this quadratic function. Look at the form it has, and all the I'm sorry, all the variables, all the coefficients, and so on. This is exactly the same as this. It has the same shape. Even though we're calling the coefficient of the x squared, we're calling it m, and the coefficient of x, we're calling it n, and the constant, we're calling it r, it doesn't make any difference. It is the same thing as this. Okay, try to understand that. Okay, don't get married in this case to a, b's, and c's. It's not always written in that way. So that's very important. Okay, another thing that is very important is for you to understand that if you have a standard form like this of a function, and you are told to go from the standard form to the factor form, so you want to shape this into looking like this, that doesn't mean, listen, that doesn't mean that this number in here, this a, has to be the same as this a. Because they don't in the general case. Okay, again, all these variables a, b, c, p, q, k, h, and that's it. They mean numbers. They don't have to be the same. In this case, they don't have to be the same number. Okay, the correct way in which you read this is the following: f of x equals some number times x minus some number, close parentheses, times x minus some other number. Okay, a, p, and q don't have any significance on their own. I could call this I could call a in here, I could call it c if I wanted, but in most cases it's not done in that way. So Please understand that the variables or the coefficients in mathematics are just dummies. They don't mean anything on their own other than numbers, okay? They don't have a special significance. It's like when people get extremely used to seeing this. You have a right triangle, and in 99% of the textbooks you will find that this side is always called C, and this side is always called A, and this side is always called B. Okay, and then the Pythagoras theorem is always written in this way: c squared equals a squared plus b squared, or the other way around, a squared plus b squared equals c squared. Most people, when I show people this, they're gonna immediately say that's the Pythagoras theorem. Okay, but what if I show them instead something like this: m n r, and then I write this: r squared plus n squared equals m squared. If I show those people this thing, they're gonna hesitate a little more because they're not used to this, to the using of these variables to express the Pythagoras theorem. But it's exactly the same. All of this is exactly the same to all of these. The letters or the variables that you use have no significance on their own. Please understand that. That's very important to understand, and that's one of the sources of much confusion. Okay, so now we have three forms, and like like you can imagine, we're gonna have to convert from one to the other. But before we do that, let's do a little exercise. Okay, I'm writing here the three forms of the quadratic function: the standard form, the factor form, and the vertex form. Do you have to memorize them? No. As I always tell you, no, 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 no. You can always look them up. Okay, so examples. Let's analyze these seven functions, quadratic functions, and let's try to identify in what form they are, or whether they are in any form, because they may not be in any one of these forms. Okay, that's not a requirement. So let's see. The first one, f of x equals 3x squared plus 2x plus 1. Look at it. Look at this, and try to see if it completely matches one of these three forms. I give you some seconds. Complete match. So it was the first one, right? It was the standard form. This is written in the standard form because it matches completely this. We have ax squared. We have a x squared, a number, right? And then plus, and then plus, and then some number times x. So we have here some number, which is 2 times x, plus another number alone. We have in here a number alone. So this is the standard form. Okay, number 2, f of x equals all of this. Look at this, and again look at the these three forms, and tell me whether it matches completely one of them or not. Completely, signs and all. So as you can notice, this one almost looks like the standard form. Almost. The reason for the almost is this minus, because the standard form doesn't have a minus in there, it has a plus. Can you see? But other than that, it's pretty much the same. So what we do is this: we consider this and we say, okay, can we reshape it just a little so that it looks perfectly equal to the standard form? Can we do that? Okay, let's try. I'm gonna write it down in here. Fx equals 5x squared minus 4x plus 2. And it's very simple, guys. All I need to do is this. It's extremely simple. It's so simple it's dumb. We have this, and all I have to do is this: put a plus in here, and then I can surround the minus 4 in between parentheses. You're gonna see why in a moment. Plus 2. Okay, like that. Can I do that? Yes, because by inserting a plus in here, I'm not really changing this expression, right? It remains the same because plus times minus is minus. So it doesn't change. It doesn't change this expression. It only rearranges it or reshapes it, so to speak. Now, is this completely in the standard form? Yes, because we have a number times x squared, a number times x squared, plus a number which is minus 4 times x, a number which is b represented by b times x, and then plus, and then plus, and then 2, and in here we have the constant. So this is perfectly into this standard form. So as you can see, by just inserting, that was the trick, just inserting this plus in there. By doing little rearrangements, you can bring one of the forms that almost looks like one of these into looking like one of these perfectly. Okay, you're gonna notice that in a moment. So we can classify this as in the standard form because by just a single trick of algebra, we can make it look like the standard form. Okay, so we can say this. Okay, now look at the number 3 and tell me whether it looks like one of these. Try to identify. So as you could see, it completely matches the factor form, right? Variable by variable, coefficient by coefficient, sign by sign, number, number, and then binomial in the form x minus b, or in the form x minus some number, which is what we have here, x minus some number. And then another binomial in the same form, x minus another number, x minus another number. So this is given in the factor form. Good. Now look at number 4 and do the same. Let's do the same thing. Look at it, look at this, and look at all these forms. So it almost matches the second one, right? Save for the signs, it looks pretty much the same. The only difference is that we have pluses in here instead of minuses. So one more time, can we reshape it by doing a little trick, a little algebraic trick? Yes, and that one happens in this way. F of x equals, I'm going to write it down again, 3 times x plus 1 times x plus 2. Okay, so this is the function. And the trick is very simple. The trick is this. I'm going to write 3 that multiplies x, and I'm gonna insert now a double minus, so to speak. I'm gonna do this. Look, I'm gonna rewrite this binomial x plus 1 in this way: x minus 1, and I close parentheses. Okay, x plus 1 is equal to x minus 1. It's clear, right? Because minus times minus is plus, and the same here. X minus 2, close parentheses. These two binomials are completely the same as these two. They look different, but they are the same. And now that I have done that little algebraic trick, now this form of the function, now this is in the factor form. Why? Let's see why. We have number, and then we have a binomial of the form x minus another number, which is what we have in here. We have a binomial in that form. Look, listen, x minus this number, which is minus 1. Can you see? X minus this number. That's it, guys. And the same for the other binomial. X minus some number. X minus some number, which happens to be minus 2. So this is perfectly in the factor form. This one wasn't. It was almost in that form, but now this is. So again, we can classify this as being in the factor form with just a little of doing this little thing in here. Okay, look at the next one, number 5. And do the same thing. Try to look at it and see if it matches one of these perfectly. Okay, so it matches perfectly with the vertex form, right? Exactly. We have number, some number, and then a binomial of this form, x minus some number, x minus some number, and that binomial is raised to the square. There you have it. And then we have plus another number, plus another number. So this is already perfectly in the vertex form. Okay, good. Now look at the next one, number 6, and do the same experiment. Well, the same exercise. Okay, it almost looks like the vertex form, right? Almost, but not completely. And the reason is the signs, again, the signs. We have a minus there, and we have a plus here. And we have a plus here, and we have a minus here. But that's nothing that cannot be fixed by doing a little trickery. I've been telling you that a lot. A lot of what mathematics is just doing tricks. So I'm gonna shape this function into looking perfectly like this, and it's the same idea. I just have to introduce some double minuses and that stuff. So here we go. We have 2 times x, and this binomial has to be in this form. So I'm gonna shape it in that way. I'm gonna say minus 1 to the square, like that. Can you see? Now since this is equal to all of this, okay, then I could do that perfectly fine. And now all of this part at least, has the same shape as all of these. Can you see? Because we have a number, and then a binomial of the form x minus another number, x minus another number, raised to the square, you see? And now this minus 7, it's the same idea. What I'm going to do is this. I'm just going to introduce a plus minus 7. It's because it's going to be the same, right? Minus 7, it's the same as plus minus 7. And now I have this plus in there. Can you see? All of this now, all of this expression, all of this equation has exactly the same shape as all of this. Exactly. Make sure that you understand why it matches perfectly all the requirements. Number, binomial in the form x minus some number, binomial in the form of that, x minus some number, raised to the square, plus some number. So this is already in the vertex form completely. Okay, so since number 6 was almost in that form, we can classify it like that, okay? Abusing a little bit of the definition, because this is the definition of the vertex form. In these cases in which we shaped it to look like one of these, we are abusing, okay? This is not really in the standard form, but almost. This is not really in the factor form, but almost. And the same for this, okay? We are abusing a little bit of these definitions. And the last one, look at this. Look at it and tell me whether it looks perfectly like one of these. Give me some seconds. It doesn't, right? It doesn't look like any of these, because we have, I mean, because it just doesn't, okay? Because of this. And so what do we say? Okay, we say that this form of the quadratic function doesn't match any of these common forms of the quadratic function, okay? I don't want you to get the idea that these are the only ways in which a quadratic function can appear. This is a perfectly good quadratic function. We can shape this into any of these forms, okay? But so far, it's not, in its current state, it doesn't match any one of these. But that's not a problem, okay? Don't discriminate this little guy in here. We can make it look like any of these by doing some algebra. So that's how this works, guys. These are the three forms. You're gonna get used to them, and you're gonna learn to recognize them. But again, memorization is not the best idea. It's a good idea, but I don't want you to understand that memorization is learning, because it's not, especially in mathematics. Try to investigate what mathematicians think of memorization. I mean, top mathematicians, like the ones that you know that win the medals, and I mean, incredibly smart people. They don't memorize at all. They never memorize. Okay, so number two, subtopic number two for today. We want to go from one form of the function to another, and the simplest case is this ones. Okay, when we have this instruction, put the following forms of the quadratic function into standard form. I'm going to remind you of what standard form was, because I didn't write it down here, sorry. The standard form is this: f of x equals ax squared plus bx plus c. This is the standard form. Okay, perfect. Now, let's do number one. F of x equals 2 times x minus 2 times x minus 1. What form is this, guys? This is the factor form. It's perfectly in that way. And how do I go from this form, from the factor form, to the standard form? It's extremely simple. All we have to do is multiply everything. We have this function, and now I just multiply all of this stuff. So I'm gonna first begin with the binomials. So we have x squared, and then x times minus 1 minus x, and then minus 2 times x minus 2x, and then minus 2 times minus 1, we have plus 2. And then we multiply the 2 times all of this, 2x squared minus 2x minus 4x plus 4. So, it's very simple algebra, right? And then we collect like terms. We have this and this are like terms. So we get 2x squared minus 6x plus 4. And we are done. We are done. This is, as you can see, in the standard form. Look at this and look at this, and it matches almost completely, okay? Maybe we should add the plus that I told you. I'm gonna do it in here, very, very small. F of x equals 2x squared plus minus 6x plus 4. Now it looks perfectly like this, because we have to have the pluses, okay? Those pluses. So that would be the end product. This is almost the same, okay? But this is like the definite most perfect answer, so to speak. Next, number 2, f of x equals 3 times x minus 1 raised to the square plus 2. This is in the vertex form. And how do we go from the vertex form to the standard form? Following the same idea. We just multiply everything that there is to multiply or expand, and that's it, right? 3, I'm going to first expand this binomial. So x minus 1 to the square is x squared minus 2x plus 1. And then plus 2. And then we multiply the 3 times this trinomial, 3x squared minus 6x plus 3 plus 2. And then we collect like terms. In this case, only the coefficients or these constants are like terms. And we're done. Okay, we're done. One more time. Save for the little in here, the little nuance of the minus of this minus, but it's very easily corrected. F of x equals 3x squared plus minus 6 times x plus 5. Now this is perfectly matching the standard form, as you can see. Okay, so this will be the most perfect solution, but this is also okay, almost. And number 3, f of x equals 2 times x minus 2 to the square minus 2x. This doesn't match any of the common types that we're going to see in the semester, which is the standard form, the vertex form, or the factor form. It doesn't match. But so what? Can we shape it into the standard form? Absolutely. Let's do it. And it's basically going to be the same thing. Try to do it on your own and then compare with my solution. I'm going to shut up and just do it. So this is what I get, guys. I give you some seconds to finish and try to see if you got the same. Okay, so as you can see, going from any form of the function of the quadratic function, whether factor form or vertex form or any other form that may not have a particular name, it's very simple. Okay, going into the standard form is very simple, extremely simple. Okay, we just do a lot of arithmetic and multiplications and expansions of exponents and so on. It's very simple. The thing that is not very simple is going backwards uh, from the standard form to the factor form or the vertex form. Okay, it's not as simple as this, but it's not that difficult either. So let's do it. Which is this instruction: put the following standard forms of the quadratic function into factored form. And I'm reminding you of the factor form, the way it looks. Okay, it is this one. So we have to shape these two functions so that they now look exactly in this way. Exactly in this way. Okay. And uh, I apologize one more time because I don't like to do what I'm gonna do next. I hate it, but I'm sorry, guys. Due to the time, I'm not able to explain in detail the reasons for many things. I'm so sorry. I can't. I just can't. It's impossible. I'm just gonna tell you how to do it. Okay? How to go from this standard form into the factor form without any real explanation. Okay? It's just a mechanistic way of doing it and learn it like a parrot, so to speak. I hate this, but I cannot do it otherwise. So apologize. I apologize, please. So the first function, let's write it here. F of x equals, and I apologize because that's not what we're supposed to do in IB, like just follow instructions like like servants or something. No, and as much as I can explain to you, I do. But in this case, we have very little time. Okay, so this is the function. Okay, the first thing I want you to do is this. I want you to make f of x equals to 0. And if you want, rearrange the terms. Okay, flip the terms. The right side, put it in the left side. That's because that's more uh, common for the mind. Okay, we are used to look at this expression in this way, at this equation, instead of the 0 being on the left. But it's the same. Okay. Okay. Next, what I want you to do is this. I want you to solve this quadratic equation, to solve it, and in most cases, you're gonna require the quadratic formula. And that stuff you should memorize by now. Okay, that's one of the few things that you have to memorize. So I'm gonna apply the formula already. X will be minus b, which is 3, plus minus the square root of b, which is 3 to the square, minus 4 times a, which is 2, times c, which is minus 2. All of that over 2 times a, which was 2. Okay, so we have all of this stuff. Now reduce it. Simplify it as much as possible. Let's go. Minus 3 plus minus the square root of 9. And then all of this, from this minus all the way up until the end, that's going to be equal to 16, right? Plus 16. All of this thing. That's going to be plus 16. Make sure. Over 4. And I'm going to continue developing this simplification on this side. That's going to be equal to minus 3 plus minus the square root of 25 over 4. And that's equal to minus 3 plus minus the and plus minus 5 over 4. And finally we get the two solutions, one with the plus, one considering the plus, one considering the minus. So let's consider the plus. Minus 3 plus 5, how much is that? It's 2, right? 2 over 4 is 1/2. So that's one of my solutions. The other solution, considering the minus. Minus 3 minus 5, how much is that? Minus 8. Over 4, that's minus 2. And I'm done. These are my two solutions for this quadratic equation. Okay, and why did I need to get these two solutions? Okay, in order to write all of this in this form, and this is how the process ends. I'm gonna do it in blue over here. So this function, my original function, which was in standard form, can be written in this way by doing this. Okay, guys, I made a mistake in the last example. So uh, remember, we were working on this one, right? By doing by solving the quadratic equation equal to 0, and we got the following numbers. In the end, we have these two solutions. X equals, it was 1/2, and x equals -2, right? Those were the solutions. Okay, now what do we do next? What do we do with these two solutions in order to write this function, which is in a standard form, in this way? Okay, let's finish it. So what we do is this: we write f of x, and then first I have to write a number, a single coefficient, some number, and that number will be also the same coefficient of the x squared, this number. Okay, 2. And then I need to write two binomials in these particular ways: x minus some number, and the same for the other. Okay, what are going to be those numbers, p and q? They're going to be these values, guys. Okay, 1/2, and the other, x minus, the other will be this. And that's it. We are done. This is the factor form of this function, of this quadratic function, which is in the standard form originally. Okay, look it up. I mean, look at this function, and try to understand why all of this is perfectly matching the factor form. Can you see it? It matches perfectly. Now you want to confirm, you can multiply all of these. I'm going to do it very quickly. Okay, all of this. So here it goes, very quickly. 2 times this binomial, I'm going to get 2x minus 1, because 2 times 1/2 is 1. And then this other binomial, after I multiply minus times minus, I get plus. And then I have to multiply these two binomials. FOIL, let's do it very quickly. 2x times x, 2x squared. 2x times plus 2, I get 4x. Minus 1 times x, I get minus x. And minus 1 times plus 2, I get minus 2. We collect like terms, and we get 4x minus x plus 3x minus 2. So there you have it. Can you see? Okay, f of x equals 2x squared plus 3x minus 2, which is the same standard form that we had at the beginning. So this is just a confirmation that our final result, our final product, indeed is the same as this one, only in another form, namely the factor form. Okay, so let's do the other one very quickly, very quickly. This one, number 2. Okay, let's write it down in here. Okay, we have it completely written down, the same. And again, make f of x equal to 0, so that now you have this equation to solve this equation by means of the quadratic formula. Simplify all of this expression, all of this, from this minus up until the 3, we're gonna get, it's gonna be 12 times 3, 36, plus 36. It's gonna be plus 36. Yeah, is it? No, 24. 4 times 2, 8. Yeah, plus 24. I'm sorry. Over minus 4. I'm going to continue over here. 1 plus minus the square root of 25, right? So it's going to be, in the end, it's going to be 5. Because all of this is the square root of 25, which is 5. Over minus 4. And I can now write the two solutions. X equals 1 plus 5, 6 over minus 4. Or in other words, negative 6 over 4. Negative. And the other solution will be 1 minus 5, which is minus 4, over minus 4, which is going to be 1. So I got my two solutions, and now I can finish the problem. So this function, which is in the standard form, can be written down in the factor form in this way. We began in this way. F of x equals my first number, okay, this number in here, which is always the coefficient of the x squared. In this case, it's minus 2. Minus 2 times two binomials in the form x minus some number and x minus some number. What are those numbers? These two solutions that you got in here. So it's going to be x minus 6 over 4. Oops. Okay, I'm cramming it. And the other one is just 1. Okay? You don't have to write the 1 in between parentheses, okay? Because it has no ambiguity. But when the number is negative, it's actually very advisable. This looks very bad. So I'm gonna put x minus 6 over 4. Okay, and this is it, guys. This is already in the factor form, and it's the same as this. If you multiply all of this stuff, all of this, you will get this in the end.